Determine if the sequence converges or diverges. If it converges, determine its limit. In first part, we got general term 2 raised to negative n, which is same as we can write in this way, to put on the bottom. So 1 over 2 raised to n, or we can even say 1/2 raised to n. So a number raised to n means a geometric sequence. Okay, geometric sequence. Something like a number times r, another number raised to n. And this number is like 1 and r raised to n. The common ratio is 1/2. Okay, and we know that when the common ratio is 1 or in between -1 and 1. Okay, common ratio could be 1 but not -1. So inside here, if common ratio is bigger than 1, bigger than -1 but less than or equal to 1, the sequence converges. Okay, when it gets bigger and bigger, in this case 1/2, and really big, it gets smaller and smaller, eventually goes to 0. Okay, this sequence converges to 0, and that happens every single time. At 1, when r is 1, it will be always same term like a. Then the sequence converges to a. In other cases, if r is in between -1 and 1, the sequence converges to 0. The limit will be 0. Okay, in this case, limit n going to infinity of 1/2 raised to n will be 0. So the sequence converges to 0. So we can write the sequence converges to 0. Okay, in second part, we got 3 raised to n times 2 raised to 1 minus n in two places. So we need to simplify. This is 3 raised to n. 2 raised to 1 minus n is like 2 raised to 1 minus means 2 raised to n on the bottom. Now 3 raised to n, 2 raised to n can be combined. 2 raised to 1, that's the number 2. 3 raised to n, 2 raised to n means 3/2 raised to n. Now this matches with our geometric sequence with a is 2, not important, r is 3/2. Okay, that is bigger than 1. If this is bigger than 1, then the sequence diverges. So the diverges means the limit will be infinity in this case. The sequence diverges. Why? It's a geometric sequence with r equals 3/2 bigger than 1. Okay. Now the third part is 4 raised to n. Oh, this is like Rn, like part 1. You can put it in this way. Arn. A is 1. Okay, geometric sequence with common ratio 4, which is bigger than 1, so diverges. The sequence diverges. Again, it's a geometric sequence with r equals 4 bigger than 1. Now here's the last part. Okay, this is 2 raised to something, so let's find the limit. Limit n going to infinity of 2 raised to, okay, this is on the exponent 2n over n plus 1. So this is a continuous function, so limit can be moved here as we saw in calculus 1. 2n over n plus 1. Now let's find this limit on the top. We got limit, you don't have to show this work, that's why I'm showing in different color. This limit depends on the leading terms, because n approaches to infinity. Leading means n, 2n over n, so n cancel, so this is simply 2. That means this limit is 2, so 2 raised to 2, 2 squared, so 4. That means the sequence with these common terms, the sequence converges to 4. The sequence final